Hello viewers, today we will discuss about the polar representation of a complex number or argand diagram. The plane what we use here is called complex plane or Gaussian plane. First we consider a point here, and if you draw two rectangular axes here about this point, so this point is O, this axis we name it X, O, X dashed. Another is Y, O, Y dash, and they are perpendicular to each other. So first one, X O X dash, is called X axis, and this is Y axis. We take a point A on X O X dash such that OA is equals to 1 unit. Let we take Z is equals to X plus IY, and it is a complex number, and let P, we consider a point P here. Let P be a point whose coordinates referred to the axes are X, Y. Now, if we drop a perpendicular here, so X is equals to this much and Y is equals to this much. Now, the point P of the complex plane represents a complex number Z is equal to X plus IY. This way, to each complex number, we can find one and only one point in the complex plane. Conversely, with every point P of the plane, we can associate one and only a complex number X plus IY. If Y is equals to 0, then Z becomes X plus 0I is equals to X, and which is real Z. And this we consider a corresponding point lies on x-axis, and this point represent real Z. Thus all the real numbers x which is real Z considered as a complex number correspond to points on x-axis. X-axis means here. all points on this x-axis, x dash to x, and hence x dash ox is called real axis. Or axis of reals. Similarly, if x is equals to 0, y dash, if x is equals to 0, then z is equals to 0 plus iy equals to iy, where y also belongs to R, which is purely imaginary number. And the corresponding point lies on y-axis. Corresponding point lies on y-axis, all purely imaginary numbers. Corresponds to point on y-axis. Or axis of imaginary. So thus we obtain two axes. One is real, other is imaginary axis. And any point in this plane represent a point, and this plane is called argand plane or Gaussian plane or complex plane. Now, if the point P dash, let we consider a point P dash. This is our P, x, comma, y, and we consider a point P dash as x, comma, minus y. So it will be here. This side is positive side of x and this is y. We name it P dash x minus y. and this represents the complex number. Z is equals to x minus I y. This is the conjugate of Z. And this is also the mirror image of P on real axis. This is the mirror image of P on real axis. Similarly, we consider a point P dash. P double dash which is the reflection of P Now, if you want to locate this one, first draw this x-axis, y-axis. This is our origin. If this point is P, this point P double dash, which is the reflection of P on the origin. The coordinates of P is minus x minus y. And corresponding complex number is minus z. So P is x comma y, P dash x comma minus y. So this is represent the complex number z bar, that is conjugate of z, and here z, it is minus z, and this is z. This is real axis and this is imaginary axis. Now here OA is equals to x unit and AP is equals to y unit. And this is a right angle triangle. So using Pythagoras theorem, we can write OP square is equals to OS square plus AP square. Now OA equals to A, so this becomes X square and Y square. Therefore OP equals to under root X square plus Y square. This is called modulus of Z. Or shortly you can write mod Z. Now suppose there is a point P, the order pair is 4, 3, corresponds to the complex number Z is equals to, or Z1 is equal to 4 plus 3i. So if you marked 1, 2, 3, 4, and then 1, 2, 3, and if you join, so you get the point P. Corresponding complex number is Z, which is equals to 4 plus 3i. Similarly, the point P dash, it is minus 4 and 3, represent the complex number minus 4 and 3. Here the corresponding complex number, if you write as Z dash, which equals to minus 4 plus 3i. Similarly, minus 4 minus 3i. Now this point is 4 minus 3i. And in all the case, the mod of Z1 is equals to root over 4 square plus 3 square is equals to 5. minus 4 square plus 3 square, that is also 5. Minus 4 whole square plus minus 3 whole square, which is equals to 5. So the length of all this five units, 5 units, so they lie on a circle of radius 5. So this also proves that there are different complex numbers. Their modulus is same. Okay, thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.